Objectives for today: to solve mixture problems. The learning targets are proportions and percents. Know how to use each and when to use them. Example number 1. A 600 liter mixture of water and acid contains 5% acid. If 150 liters of water is added, then what is the new percent of acid? You are starting with 600 liters. To find out how much acid you have in terms of liters, you multiply the amount total, 600 liters, by the percent of acid, which is 0.05. And when you do that, you should come up with 30. That represents 30 liters of acid. Now, 600 is what you started with, and you're going to add 150 to that. You're adding 150 liters of water to the container. So if you start with 600 and you add 150, you're going to end up with 750 liters total of a mixture of water and acid. But what the question is asking is, what is the new percent of acid after you've added that water in here? You started with 600, you're adding 150 worth of water. To find out what the percent of new acid is, you start out with how much acid you have now, which is 30 liters, and divide it by 750 liters, which is the new total. When you do that, you're going to have 30 divided by 750. That comes out to be 0.4. Nope, that's 0.04. Multiply 0.04 by 100 to come up with a percent of 4. Practice number 1. A 325 liter mixture of water and acid contains 11% acid. If 100 liters of water is added, then what is the new percent of acid? Solution for the practice. You have 325 liters of a total mixture of water and acid, but 11% of that is acid. To find out how much acid you have in liters, multiply 325 by 0.11 and come out with an answer of 35.75. Now you're adding 100 liters of water. That means you started with 325, but you're adding 100 liters of water. So your new total should be 425. To figure out what the new percent of acid would be, you divide the number of liters of acid by the total number of liters in the new mixture. When you do that, you come back with a number of 0.084 and some change. You have to multiply that by 100. When you do, you get 8.4, but you're rounding to the nearest percent, so it's got to be 8%. Another example. This is the second type of problem, and this one starts with 800 liters of a mixture of water and acid, and the percent of acid is 9. How much water must be added to obtain a 7% level of acid? Well, the first step is 800 times 0.09. That will give you how much acid you have in terms of liters. So 800 times 0.09, and that will be 72 liters of acid. And now we want to find out what the new total is. So if we start with acid, and that is 72 liters, and we know that the percent of the acid is going to end at 7%. That means 72 over the new total, which is what X represents, should give me 7%. 7% as a fraction is 7 over 100. So again, we found the number of liters of acid, and we set that equal to 7%, which is what the new percent is going to be, but you have to divide 72 by the new total, but we don't know what it is. That's why we made it X. So once you have your proportion set up, remember this is the percent here. This is the number of liters of acid. 7 over 100 is the percent, and this is the new total we don't know. Cross multiply to get 7x equals 7,200, and divide 7,200 by 7. And 7,200 divided by 7 comes out to be 1,028.57, and that is the new total. But keep that in your calculator, because what you need to do with that amount, 1028.57 and some change, is subtract from that 800. So while it's still in your calculator, hit minus 800 and come back with 228.5714. But on these practice problems, I want you to round to the nearest liter. So that would be 229 liters of water that had to be added to obtain a 7% level of acid. Here's a quick review. We started with 800 for our total mixture. We multiplied by 9% acid. That gives us 72 liters of acid. The percent that you're going to end at, the 7% of acid that's going to happen after you add some water, is 7 over 100, and that's equivalent to your amount of acid over what the new total would be. We don't know the new total. So we cross multiply and came up with this. We did the division to come up with this, and then you're going to leave that in your calculator and subtract 800 from it, because that was the beginning. If you start with the end and subtract the beginning, that'll leave you with how much water was added to the container, 229 liters. Another practice problem. 675 liter mixture of water and acid contains 14% acid. How much water must be added to obtain 8% acid? We have to figure out how much water must be added in order to get an 8% mixture when you start with 675 liters of water and acid, and 14% of it is acid. So start with 675 times 0.14. That will give you the number of liters in acid that are in the mixture, and that comes out to be 94.5. Alright, we have to find the new total, because the amount of acid, 94.5, over the new total after the water is added will give us 8%. Since we don't know this new total, we make it x, and then we cross multiply to get 8x equals 9450. Divide 9450 by 8 and come up with an answer of 1181.25. Now this represents the new total. So if we start with the new total and subtract what we started with, 675, then that should tell us how much water was added. And we come up with 506.25, but if we're rounding to the nearest liter, that should be 506 liters of water. Another example. A mixture contains water and acid. The mixture has 7% acid. If adding 400 liters of water makes the acid 5%, then how much was the total mixture in the beginning? So up here, a mixture contains water and acid. We have no clue what that is. But like with the other problems, we always multiplied the beginning amount by 7%, in this case, by the percent of acid. So let x equal the total amount that you have at the beginning, and multiply it by 0.07, which is the percent of acid. And what this equals is the amount of acid you have in liters. We just can't do anything with it yet. Now you're going to add 400 liters of water. So whenever we add water, we have to figure out the new amount. We don't know the beginning amount. It's still X. But we do know we're adding 400 liters of water to it. So X plus 400 is our new total. So we put new total, and that's in terms of liters. Just like with the other problems, we divided acid by the new total to come up with the new percent. We do the same thing here. 0.07x is the acid amount, and then x plus 400 is the new total from here. And it equals 5%. So that's 5 over 100. From there you cross multiply. Cross multiply this way first. That would be 7x equals, and then you distribute this 5 here to the x plus 400. It's 5x, that's 5 times x, and then 5 times 400 is 2,000. We have to solve this up here because I'm out of room. Move this 5x over and make it minus. 7x minus 5x equals 2,000. Subtract to get 2x, and then divide 2,000 by 2 to get 1,000. Now 1,000 is in terms of liters, and that represents what the mixture was to start with. And that's what we're looking for. How much was the total mixture in the beginning? So 1,000 liters is the answer. Here's a quick review in case anybody needs it. As with every other problem we do, we start off by multiplying the percent of acid by how much you have in your total. Here's our percent of acid, and here's our total. It's X. We don't know it. So that's just our acid total in liters. And then when you add water, you're adding it to the beginning amount, but we don't know it still. So it's X plus 400, and that's the new total. So anytime you have the amount of acid and the new total, you can divide them to come up with the new percent, 5 over 100. Cross multiply this way first to get 7x, and then by this way, 5 times x is 5x, and 5 times 400 is 2,000. Now move your 5x over to the left, and we had to come up here to do that. 7x minus 5x is 2x. Divide your 2,000 by 2 to get 1,000.